Today I'm going to be explaining the difference between current and electron flow. So let's look at a battery, and it's hooked up to a light bulb. This light bulb is going to be drawn sideways. And you may ask, what direction is the current? Well, we define it from positive to negative. And this negative we sometimes call ground. So, this is current flow. Now, let's look at electron flow. So I'm going to zoom into a wire, and we're going to look at what the electrons are doing. So let's say this is the positive side, and this is the negative side. So somewhere down the wire this is ground, somewhere down the wire this is positive, and somewhere on the wire we're going to have a resistor, some kind of load. So let's define electrons as orange, and we're going to define holes as these little gray circles. So we know that current flows from positive to negative, which is, like I said, defined. And we're going to look at the characteristics of these electrons. So what have we found? What we found is that electrons actually jump over. These are free electrons, remember, and they'll jump over into the hole. So they'll fill this hole. So now this is an electron, and now this is a hole. And this process continues. Jumps over to the next hole, then the electron goes in this hole, and this becomes a hole. Obviously, because if you take the electron out, all that's left is a hole. So, you can think of it as current I is in the direction of the holes, and the electron flow is actually in the opposite direction, which is quite interesting. And this makes sense because we have an electron, and we know that it's negatively charged, and it's going to go away from the negative sign and towards the positive sign, which makes sense. Another very convenient way to think about current is if we have a ball and we have earth, or the ground, so you can almost think of this as the ground in our circuit. And this is at some level, some height of h, and you know that the energy with this ball at height h is equal to mgh. That is just the potential energy of the ball. And you know if you let go of this ball, it will fall to ground, and eventually it'll be at ground. And you can almost think of this with our circuit, positive to negative. It's going to go from higher potential to lower potential, and that is the direction of our current I.